In this video, I am going to discuss about capacitors. What are capacitors and how does a capacitor works? I show you, you can see this you might have seen used in electrical fans, electric coolers, electric motors, etc. You can see this is the capacitor and its capacity is measured in farad, and farad is very bigger unit, so it is in microfarad. You can see this is 3.15 microfarad. I have one more capacitor, small size capacitors, and it consists of two plates, two terminals, and you can see this is having certain voltage also written over it, and it is 25 volt. You can see 25 volt and 1000 microfarad. So you know, this is the symbol of capacitor. Two plates separated by a very small light emitting diode, and it can glow if we will connect it with a battery. So let's check whether it works or not. I have a very power source, small voltage power source. So let's check whether this LED works or not. So you can see this is the source of current. So we can check the voltage of battery or this is working or not. Let's check. Okay, if it will, I have a galvanometer. The galvanometer will show deflection if there is this battery is charged. So surely this must be charged. You can see there will be a deflection in the galvanometer. Yeah. And you know, galvanometer is used to detect the direction of current. If I will reverse the electrodes or terminals, then the direction of current in the galvanometer will reverse. You can see it is showing other side. Okay, now I touch this terminals with this LED. Let's check it glows or not. No, it means it may be in reverse bias because LED works only in forward bias. So let's check. Okay, it's working. It is in forward bias. It's working. Yeah, you can see it means this terminal is positive and this is negative. It is working. Now if I connect the same LED with these two terminals of capacitor, it will glow or not. Let's check. It is not glowing. It means this capacitor is fully discharged now. It is not giving any supply to it. Now first we will charge this capacitor. Let's charge this capacitor. For 5 to 7 seconds only we can charge it, and after that we will connect it with the LED. Okay, this capacitor also have two terminals, one is negative, another is positive. So this one negative, this one is written over it. So I will connect the negative terminal with the black wire, this one. So this should be properly charged. Positive terminal to the positive electrode, negative to negative electrode. Okay, now it is almost maybe charged. Okay, now if I will touch the two electrodes of this capacitor to this LED, it should glow. It should glow. Okay, it is glowing, and you can see the brightness of the bulb is decreasing continuously. It means this capacitor is a source of electricity for very small interval, for short interval. It is almost discharged. Now this capacitor is again discharged, so we can recharge it with the help of battery. Now if I use the light, now this capacitor is fully discharged. I can check with this galvanometer also whether it is charged or not. There is some charging left or not, we can check with this galvanometer. Okay, there is something charged, but again its reading is 0. If I reverse the terminals like this, deflection was on other side, but again it comes to 0, no deflection. It means now this capacitor is fully discharged. It is fully discharged. Okay, so my next point is how this light is converted into electricity. You know, you might have seen the solar plates over the rooftops. So light can be converted into electricity. So we will check using this light. I have this source of light. If I will focus this light for some time on this capacitor, and capacitor is nothing but the two plates separated by a very small distance, very close together, and it has no potential difference. Two electrodes are at the same potential. So if I focus this light for some time over this, you can see I will focus this blue light for some time over it. You can see there are circular rings shown between these two electrodes, and for 10 to 15 seconds at least we should focus the light on it, so that there should be some potential difference created between the two electrodes. Earlier this potential difference was created with the help of this battery. Now can light create the potential difference? I want to check it, and we will see then how much potential difference is there. So the galvanometer must show some deflection. Okay, now I will use this galvanometer to check whether there is some potential difference created or not. The galvanometer must show some deflection if I will touch these electrodes of the capacitor with these leads. You can see just, okay, it is showing, it means there is some again potential difference created, but the capacitor, you know, for very short interval it can gives the current, so again it is discharge. Again you can show it is showing the deflection in other direction, so it means light can be converted into electricity in this way. So this is this I want to show how light is converted into electricity with the help of this capacitor and this light, source of light, laser light. So I wanted to show it. It is very easy and non-conventional source that light can be converted into electricity. You know, sun is a vast source of energy, so we should harness the solar energy, and that is the good idea. So capacitor is used to give the potential difference for very short interval of time, so it ultimately store energy in the form of electric field. Thank you.